This lesson is going to mix together arithmetic sequences series, geometric sequences in series, and our challenge is going to be trying to recognize which one it is and which formula to apply. Is it a sum? Is it a term? Is it arithmetic or geometric? But there are some clues. So let's look at the first example. Each year, a machine loses 15% of its value. As soon as you see a percent, you know the word geometric is going to apply. Because percentage of something means you're multiplying. Okay? The year after it was bought, it's worth $5,100. Calculate the initial value of the machine. So what they're telling us at the beginning there is U number 2 is 5,100. Can we find U number 1, basically? And we know that each year it loses 15% of its value. That's our R value. That's going to come into play. Our ratio is I need to lose 15%. So in other words, if I take my 1, my 100%, and I subtract 15%, I get 85%, or in other words, 0.85. And my value of my machine is 85% of each previous year. So if I want to find U number 1, I can definitely do that by using this nice simple equation here, R equals U2 over U1. R is 0.85, U2 is 5,100, U1 I don't know, but I can cross multiply and then solve, and U number 1 should be $6,000. And calculate the value 4 years after the machine was bought, part B. We can do that now because we have an equation. U number 4 will be U1, our initial value. Our R value, if it goes 0.85 to the 4 minus 1. Into our calculator we go. The machine is now worth $3,132.04. Part C, the machine is to be sold for $2,000. How old is it? Oh, we know a value in the sequence. At some point it comes out to 2,000. What sequence value is that? I don't know, but I'm going to solve for it. Okay, if I need to solve an exponential equation, I'm going to have to do my guess and check. Or, because I don't know for sure it's part of the sequence, I'm going to have to use some technology. Technology is handy because it can solve for unknown exponents. And this time I might want to use it just because I don't know if this is a term in the sequence or not. It didn't say it's a term. So if we put this into Y1, and this into Y2, we can figure out when that happens. Go to our equations, Y equals, we want to know when does it hit $2,000. We know it's at 6,000. Oops, missed a 6 there. 6,000. Our rate of change is 0.85 to the power of x minus 1. Now change our window. X is our number of years. We don't know how long it's going to be into the future. We know 4 years and it's already down to 3132, so maybe 10 is reasonable. Our value, we want to get down to $2,000, but it's starting at 6. So our scale there, we want to see that graph. Maybe go up to 10,000. There's our line at 2,000. Here comes our exponential decaying curve. It's going down. Our crossing. So second calc, 5, enter, enter, enter. It turns out it was between years. It's at 7.76. And that's term number. That's kind of why we can't do the guess and check. This came out to a decimal version. Okay, let's look at the next example. A jogger running along a course with a slight uphill grade covers 350 meters in the first minute, but due to fatigue covers 25 laps in each succeeding minute. What distance is covered in the 8th minute? So what's happening here? They got 350 the first minute. They couldn't quite do as much. They're down to 325, the 25 less, and so on, and so on, and so on. So the fact that I'm going down by 25, the exact same amount each time, tells me it's arithmetic. What distance is covered in the 8th minute? What is the 8th term of our sequence? So U1 plus n minus 1 times d. d is negative 25, down by 25 each time. Well, we can calculate that. That's 175 meters. Part B, how far has the jogger ran in total? There's a good word, total. Total is an S thing. And we already know it's arithmetic, so we know it's S8. So our formula for that is n over 2. And then we ask ourselves, can we use a shortcut? Do I know the first term? Do I know the last term? The first term is 350. The last term is the 8th minute, which we just figured out. So I can use my little shortcut here, U1 plus UN, U8 in this case, and calculate. I can get 4, and then 350 times 525 gives me 2100 meters. Now, if I didn't recognize to use the shortcut, I could use the long version of the equation too. It would work just the same. That's an arithmetic one. All right, last one. I'll give you guys a chance to really work on some stuff. At Bowater, they pile logs. Start with 90 on the bottom, 88 in the next row, 86 on row 3, and so on. Find the number of logs in the 8th row. Okay, so they're telling us 90, 88, 86. Arithmetic, right? It's a pattern. The number of logs in the 8th row, that's a term number. U number 8. I'm starting at 90, 8 minus 1. My difference isn't going down 2 each time. Into my calculator, and I get 76 logs in the 8th row. Part B, find the total number. I like that word, total. So S8, oh, that was not 8 this time, it's 9 this time. Okay, so S9 equals N over 2, 2 times U1, and I'm using the long one this time because I don't know the 9th term, though I could pretty much figure it out pretty quickly, so I know the 8th one. Just good practice. So 9 minus 1, and my D is negative 2. Okay, so we have 4.5 times 180, 80, minus 8 times 2. And I get a total of 738 logs. That was quick. Part C. How many rows are needed to pile a total of 880? Oh, I see the word total again. But this time, they're telling us the total. We've never done that yet. So I need it to come out to 880. I don't know how many rows there are. I know the first term was 90. But I don't know how many rows there are. I know the difference is negative 2. So I'm going to have to approach this in a different way. I'm going to have to solve this. The way we can solve it, first of all, is to simplify things. I like making things easier before we start working on them. 2 times 90 is 180. We'll expand our brackets. Okay, so negative 2, make sure it's a negative there, okay, times those things. Again, we can simplify this a little bit further. We want to make things easier before we start really doing anything. Inside the bracket, we'll get 182 minus 2n. Well, if I multiply the n over 2 through that, I'm going to get 182n divided by 2. That's like saying 91n. If I do the same thing for the next part, I'll get negative 2n squared over 2. In other words, just n squared. Right? The 2's will cancel each other out, one on the top, one on the bottom. Well, this looks awfully like a quadratic. It's got an exponent, n squared. To solve quadratics, we got to make them equal 0. So I'm going to bring everything to the left-hand side so it equals 0. Notice when I cross the equal sign, I change my signs. To solve a quadratic equal to 0, standard form, we try factoring. We think about man. Can we think of anything that multiplies to 880 and adds to negative 91? And sure enough, if we can actually come up with numbers that do that, it takes a second. And if we couldn't, we could always use the quadratic formula, but in this case we can. The numbers 80 and 11. That'll work. So, answers are either n equals 80 or n equals 11. Now, one of these answers is inadmissible. Okay? And the one that's inadmissible is the 80. Because there's no way I can make 80 rows if I'm going down 2 at a time, starting at 90. That's not mathematically possible. Right? I go down 2 at a time, means I'd be in the hole some logs by the time I get to the top of that pattern. So this one is inadmissible. In order to get that pile of logs, being 880 of them, need 11 rows solve the 880 logs. Okay. Most of today is a work period. There's a handout attached. You might want to print it off. That works through sequences and series. The tricky part is figuring out which one to do, which equation to use, arithmetic, geometric, U or S. So try it yourself, work through them, the answers are there, and if you're stuck, come see me. And that's the end of this unit. So we're going to do some review and a test next.